Welcome to Quantitative Physics Studios. In this video, we are going to do the problems which are related to the symmetrical circuit students. Here I am recalling the major things what you have learnt in previous video. In previous video, you have learnt what is the perpendicular axis of symmetry and what is the parallel axis of symmetry, and how we have to identify which one is of this. Either it is the perpendicular axis of symmetry or parallel axis of symmetry. Well, students, it was this circuit. Okay, students, here we have different resistors, and I'm identifying how to identify which one is the axis of symmetry. These are the potential points, students. Okay, these are the potential points, students, and in the problem is asking that find the effective resistance between these two terminals is at. These two terminals A and B, obviously the terminals related to the potential. These are the two potential points. What I am doing here, see, I am locating an axis which is drawn perpendicular to the potential points. Here it is making an angle of 90 degrees. Simply we call it as perpendicular axis of symmetry. Students, here in such cases, what you have to do, you have to remove the resistor which is parallel to the axis of symmetry. You have to remove this parallel to the axis of symmetry, and you know that what could happen for I am redrawing the circuit after removing that resistor. Okay, students, finally we got the circuit like this. Okay, let's say all the resistors have the same resistance. And what happens here? Here we will get these two are in series, and again these two are in series, and the effective resistance between them can be found as, here these two are in series. It turns into a single resistor, a resistor 2R, and it is the resistor which is also having a resistance of 2R, and it is R, and it is R resistors. Then these two are in parallel. You know that what you have to do. And again, the effective resistance is in series with these two. In that way, we can solve the circuit. The same thing happened with this also. Here, locate an axis. Here, already I located. Here he is asking us find the effective resistance between the points A and B. Okay, students, I'm dropping an orbital here. Okay, here this line is passing parallel to this resistance. We are going with the parallel axis of symmetry. When the axis is parallel to the potential points, then we have to remove this point. Okay, students, we have to remove this point. This has to be removed. And finally, we got the circuit like this. Okay, I'm redrawing this. Okay, students, and see. Okay, students, see this. It is R, it is a point A, and it is a point B, and these are R, 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 R. These two are in series. We will get an effective resistance. And again, these two are in series. And it turns into a single resistor. It is A and it is B. It turns into a single resistor. It is the resistor of 2R. And it turns into a resistor of 2R, and it is R. And these three resistors are parallel to each other. These three resistors are parallel to each other. Then what you have to do? 1 by R parallel is equal to 1 by 2R plus 1 by R plus 1 by 2R. It is 2 by 2R plus 1 by R. Solving this, you will get the effective resistance between these two points. Okay, students, it is the prequel actually. Right now, in this video, we are going to talk about the mirror symmetry. Okay, students, the circuits, okay, which are, what's that? In mirror symmetry. Okay, students, let's say the circuit which is drawn on the board. It is the best example for the mirror symmetry, students. Just imagine that we kept a mirror here. Okay, I'm taking it as the axis and say it is the mirror. Here, it is the pot which is kept in front of the mirror, and same we will get. I forgot to draw a resistor here, students. This part is identical to this part. Here I am taking it is the axis. Okay, students. Just imagine that it is the source which is sending the current. Let's say the current is I1 at the junction. Here it is I2, let's current is I, and it is I3. What's this, students? The current which is flowing through this resistor meets this point and it passes through this resistor as I3 ohm. Similarly, this could happen with this resistor, and this I1 passes through this one. What does it mean? No current is distributed at this point and this point and at this point also. Means what? They are at the same potential points. Okay, students. In such case, what we have to do? We have to remove the resistors which are along the same potential points. In this case, I am removing this resistor and as well as this. Okay, students, I hope you are understanding. Then the circuit could change in this way. See, the same circuit is redrawn like this. And the third set of resistors. Okay, students, it's similar to that after removing these resistors. And see, these are R, 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 and RH. And the points A and B. If it was these two, they are in series. Similarly, these two are in series also. Okay, for this part, the effective resistance Rs is equal to R plus R. Since they are connected in series, it is 2R. And the same thing happens with these two. Thus, Rs is equal to R plus R. It is 2R. Then the circuit can be redrawn like this. I'm making into a single resistor here. It has a resistance of 2R. And this one. Here, the turn into a single resistor. It's also 2R. And the third one at the bottom is also 2R. If they join them, if they join like this, okay, students, and these set of resistors are parallel to each other. You know that when the resistors are connected in parallel, the effective resistance 1 or P is equal to sum of the reciprocals of individual resistances. Let's take it as R1, it is R2, it is R3, and we will get 1 by 2R plus 1 by 2R plus 1 by 2R. Or finally, you can write 3 by 2R is equal to 1 by RP. R. Effective resistance R is equal to 2R by 3. In this way, we can solve the circuits. Here, first we have to identify what type of symmetry here. Here I showed the mirror. Actually, it is the best example for mirror symmetry, students. It is an example for mirror symmetry. Okay, students, I hope you understood. Here, the current being divided as I1, I2, I3. After reaching this point, it appears to be sum of the three and come out as the I1. Okay, students, we use the junction line actually there. Okay, here, when the currents are same, we have to remove these resistors. That's why we remove. With that, finally, we got the effective resistance. R is equal. R effective. In between the legs A and B, we got it as 2R/3. I hope you understood. Okay, students, let's solve what boards are there, students. Which is on the board. Maybe it looks like somewhat complicated, but generally we can't analyze which resistor is in series and which one is parallel. We are using the same method what we did before. Let's say it is the points A and B. It's the point A and it is point B and C. It is the key point here. Okay, imagine that a current is flowing in this way. It goes in this way and it goes. Again, this current flow like this. Let's say the current entering I and being divided as I1 and I2. And directly it is passing through this as I2. And this current, I1, is passing along this way and reaching the point I1. Okay, I1 and I2. Okay, come out as I from here. That means what? We have to think about this point. Okay, is any current is flowing through this? Obviously, according to the imagination, no current is passing. This width. And what you have to do? We have to make a small adjustment here. Actually, I am saying we have to flip this one. Flip this one up. We have to flip this one up. That means we are removing this point, this junction, and we are making it isolated like this. Okay, it is, what's that, removed from this point. Now if you take this one, you will get the circuit like this. Say students, I am redrawing. The same resistor. Where we have the resistance of R. We will draw this thing like this. And this one, which is removed from this point. And it is the same resistor is here. Okay, students, and it's going in this way. Okay. The circuit being completed. R, R, Now see students, these two resistors are in series. We are going with the collapsing method. Here, these two are series. Then we can redraw the circuit. Again like this. See? Here, it is the resistor which is here. Okay, these two are in series and turn into a single resistor of resistance to R. I did the same. Here, it is the same resistor R, and we got it is the R, it is R, it is R, okay, it is the P, and it is the A. Okay, students, see these two are in parallel to each other. These two are in parallel. And you know that when the resistors are parallel, effective resistance can be written as R1, R2 by R1 plus R2. The same thing is happening, it's R1, it is R2. Then you can write R into 2R by R plus 2R. Finally, 2R square by 3R. R and square get cancelled. We get 2R by 3. That means the effective resistance of these two resistors is 2R by 3. Okay. Again, by taking this value, we are redrawing the circuit. Then the circuit can be redrawn like this. It is the R. And this what? It is 2R by 3. And this one is R. And obviously it is R. And the second resistor is R. This is the point B. And is the A. And see students, these three resistors are in series. These three resistors are in series. Then you can write the effective resistance. R series, you know that. Summation of the three. R plus 2R by 3. That is 2R plus 2R by 3. It is equal to 6R plus 8R by 3. Okay students, this entire part becomes as 8R by 3. Here I am redrawing the circuit again. Next step, it could be like this. It is the resistor of 8R by 3. This is the entire thing. And it's the R plus R. And it is equal to 2R. And the point B. And here is the point A. And see, these two are in parallel to each other. Then we have to use in the same. R effective is equal to R1, R2 by R1 plus R2. Then we get 8R by 3 into R, 2R or 2R, 2R by 8R by 3 plus 2R. And finally we get 16 R squared by 3 divided by 6. 3 2s are 6. 6 are 8R. 14R by 3. The 3 get cancelled. R cancels with the square. It is 16R by 14. That is 8R by 7. In this way, you can solve these kind of circuits, students. I hope you understood how to solve these kind of circuits. Okay, students. Here, if you go with this one, we'll get the similar circuit. It looks like this only. Then, maybe the circuit is like this. Okay. It looks like a mesh. Yeah. It is. It's a similar circuit, but it is double. Then you have to do the same thing. You have to remove this part and keep it here. Okay. And what we did before here, find the value. And we got one more, do the same, and we will get the answer further. I hope you understood how to solve these kind of circuits. Let's meet in another video, which is about the symmetrical circuits only, particularly symmetrical cubes. Okay students, thank you for watching the video. If you like this video, please subscribe my channel.